Hi everyone, in this video I am going to teach you the factor theorem. The factor theorem states that if you have a binomial in the form of x minus h, it's a factor of f of x if and only if f of h is equal to 0. So let's go straight to the examples. Here is the question is x plus 3 a factor of x raised to 3 minus 7x plus 6? So to check if x plus 3 is a factor of the given polynomial using the factor theorem, we will follow these two steps. Step number 1, equate x plus 3 to 0, then solve for x. So that's x plus 3 is equal to 0, and then we will subtract 3 on both sides, right? So therefore, x equals negative 3. Then we will replace all the x's by the value of x, and then we will solve or evaluate. That's step number 2. So here we have x raised to 3 minus 7x plus 6. It's going to be negative 3 raised to 3 minus 7 times negative 3 plus 6. Negative 3 raised to 3 means negative 3 times negative 3 times negative 3, which is equal to negative 27. And then here we have negative 7 times negative 3, and that is equal to positive 21. And then we can add 21 and 6, that is equal to 27. And if we add these two, that's going to be equal to 0. So is x plus 3 a factor of x cubed minus 7x plus 6? The answer is absolutely yes, because f of negative 3 is equal to 0. Therefore, x plus 3 is a factor of that given polynomial. Let's go to the next one. Here is x plus 1 a factor of the given polynomial? So step number 1, we will equate x plus 1 to 0, then we will solve for x. So here we will subtract 1 on both sides. So x equals negative 1. Step number 2, we will replace all the x's by the value of x, then we will evaluate. Here we have f of negative 1 equals the polynomial. So now we have 2 times negative 1 raised to 3 plus 5 times negative 1 square minus negative 1 plus 6. This is equal to negative 1, right? Negative 1 raised to 3 is equal to negative 1 times negative 1 is positive 1 times negative 1 is negative 1. This is positive 1. Negative 1 raised to 2 is negative 1 times negative 1 is positive 1. This will be plus 1 because negative times negative 1 is equal to positive 1. So there you go. That's what we have. And then we can simplify that. That's negative 2. That is equal to 5, and this is equal to 7. So negative 2 plus 5 plus 7 is equal to positive 10. So since f of 1 is not equal to 0, therefore x plus 1 is not a factor of the polynomial. Okay, let's go to the third one. Here we have 2x plus 1. Is this a factor of the polynomial? Let's see. So to check, the first step is we will equate 2x plus 1 to 0, then solve for x. So I'm going to subtract 1 on both sides. It's going to be this. And then we will divide 2 on both sides. So it's going to be this. X equals negative 1/2. Then step number 2, we will replace all the x's by that. So f of negative 1/2 is equal to that one. Okay, so here, that's negative 1/2 raised to 3 plus 3 times negative 1/2 square minus 3 times negative 1/2 minus 2. So negative 1/2 raised to 3 is equal to negative 1/2 times negative 1/2, which is 1/4, times negative 1/2, and that is equal to negative 1/8. This is negative 1/4. This is positive 3/2. So negative 3 times negative 1 is positive 3/2. So this is going to be the outcome. Oh, wait. There you go. And then we will multiply 2 times negative 1/8. So we can cross out that 2 and 8. And it's going to be negative 1/4, right? And this is going to be the outcome. Okay. 3 times 1, by the way, is 3/4. Okay. Plus 3/2 minus 2. Now, we all know that we can simplify negative 2/8. That's negative 1/4, right? So what happens from this to that one is that negative 2 over 8 becomes negative 1/4. We simplified negative 2 over 8. So negative 1/4 plus 3 over 2, plus 3 over 4 rather, the denominators are the same. So we just need to add the numerators. Negative 1 plus 3 is positive 2 over 4, right? Okay, negative 1 plus 3 is positive 2 over 4 plus 3 over 2 minus 2. So 2 over 4, we can simplify that. Oh no, yeah, we can simplify 2 over 4. That's 1/2 here. So it's going to be 1/2 plus 3 over 2. That's 3 over 2 here. So we add the numerators. That's 4 over 2. 4 over 2 is 2. We all know that. And 2 minus 2 is equal to 0. So therefore, this the 2x plus 1 is a factor of the given polynomial. So I gave you already 3 examples. I have 2 more, but this time the question is different. For what value of k will make x plus 2 a factor of x cubed plus x squared minus kx minus 4? So what we will do is, step number 1, again, we will equate x plus 2 to 0, then solve for x. So x equals negative 2, right? So I will write it here, x plus 2 is equal to 0. Subtract 2 on both sides, so x equals negative 2. And then we will replace all of the x's by the value of x, then equate f of x to 0. That will make sure that the x plus 2 or x plus 2 is a factor of that one. Okay, so this is how we set it up. Okay, this is because of we have x cubed, so that's negative 2 raised to 3, x squared, that's negative 2 squared, minus k, okay, minus k here, times negative 2 minus 4 equals 0. Okay, negative 2 raised to 3 is equal to negative 2 times negative 2, which is 4 times negative 2, which is negative 8. This is positive 4. This is negative k times negative 2, that is plus 2k, and then minus 4 equals 0. Solve for k. There. Okay, negative 2 raised to 3, that's negative 8. Negative 2 squared, that's 4. That's positive 2k, and then just copy negative 4. Now here we can cross out negative 4, and that will leave us negative 8 plus 2k equals 8, equals 0 rather. And then we will add 8 on both sides. So that's going to be 2k plus 8, and then divided by 2 on both sides. Therefore, k equals positive 4. Okay, one last example. It's the same question. For what value of k will make x minus 4 a factor of the given polynomial? So here I will write down everything. We will start with x minus 4 is equal to 0, and then we add 4 on both sides because we're solving for x. So x equals 4, and then I will write 3 times 4 raised to 3 minus 4k 4 square plus 12 times 4 plus 16 is equal to 0. 4 raised to 3 is equal to 4 times 4 is 16, times 3 is equal to 48, right? So 4 times 4 times 4 is 64, sorry. 4 times 4, not times 3. 4 times 4 is 16, times 4 is 64. Okay, so this is 3 times 64 minus 4k times 16 plus this is 48 plus 16 is equal to 0. 3 times 48, 64 is equal to 192 minus 4 times 16 is 64k plus 48 plus 16. So 48 plus 16 is equal to 64 equals 0. Then we can add this to, that's 192 plus 64. That's 256. then subtract 256 on both sides. This is going to be negative 64k equals negative 256. And finally, divided by negative 64. Okay, 256 divided by 64 is equal to 4. Okay, so there you go. That's the factor theorem with some of the examples or problems that you might encounter involving the factor theorem. So thank you for watching. See you in my next video.